Okay, we're continuing the review for the second semester final exam in Algebra 2. At this point, we're picking up with problem 35. Okay, what we have here is a square root on the bottom of a fraction, and that's what you've got to fix. You're not allowed to have a square root on the bottom of a fraction. Now, the square root that we have down here is square root of 5. And I'd like to change that so that it's square root of 25 on the bottom, and that'll melt off the square root sign. So what I'm going to do here is multiply both sides by whatever it takes to get a square root of 25 on the bottom. Sorry about that. You have to use matching on the top and the bottom. And you can tell here that square root of 5 times square root of 5 gives square root of 25. And on the next step, we'll accomplish our goal. The square root will melt off. So whatever it takes to make that bottom turn into a perfect square. Okay, across the top, we have our 10 on the outside, and then the square root of 2 times the square root of 5 gives square root of 10. And now we finish this out. The top remains the same, but the bottom becomes just 5. That's because the square root of 25 is just 5. And then we cancel these outside numbers here, and we get a 2 there and a 1 there. So our final answer is 2 root 10. Now, to check this, you simply type the original problem and type your final answer. If they disagree, that's a bad sign. You've done something wrong. All right, on number 36, we're multiplying two expressions that contain radicals. We have a binomial times a binomial, so we're going to use FOIL, although I suggest instead using a slightly altered order of those, first, last, outer, inner. So let's start with first times first, which is 24. Last times last, which is negative 3 root 9. And then we'll concentrate on the outside, which is 12 root 3. Now, when you're multiplying, you multiply the outside numbers times the outside numbers, and the inside numbers times the inside numbers here. So by that I mean that the stuff under the radicals get multiplied together, and the stuff outside the radicals get multiplied together. So here you have a minus 6 root 3. And we got some like terms down here that I'll be combining later. But before I do that, I'm going to take this square root of 9 and fix it. It's going to be minus 3 times 3. Square root of 9 is just 3. And down here, the combination gives 6 root 3. So finishing this out, 24, 3 times 3 is 9. And you get 15 plus 6 root 3. And again, you can check this by typing this original problem and typing this answer and seeing if they match each other. Okay. This is a little more difficult. We've got a square root on the bottom. On this next problem, you can see the root 2 down there. Can't keep it that way. And we have a binomial down there. So the way this one's done is a little different. You're going to multiply top and bottom by the conjugate of the bottom. Now, the conjugate of 5 minus root 2 is 5 plus root 2. At this point, we will be distributing across the top, and we're going to FOIL the bottom. And you'll see in a minute there's a shortcut across that bottom. Okay, we get 5 root 3 plus root 6. And across the bottom, instead of first, last, outer, and inner, with conjugates, the outer and the inner cancel. So we just use first and last. First times first is 25. Last times last is minus root 4. So we get 5 root 3 plus root 6 over 25 minus 2. And that ends up being 5 root 3 plus root 6 over 23. The last thing to do would be to check and see if there's anything that would cancel out that part of it, that part of it, and that part of it. But 23 is a prime number, so we're pretty safe assuming nothing will cancel there. All right, the next one here is a 2/5 power on an x, and that one you just have to know how to do. The little number on the bottom becomes your index of the radical, and then you can either put the squared underneath, or I prefer that you learn to do it this way, put the squared on the outside. Okay, problem 39. We're supposed to solve this, and in order to do that we have to get the part that has a radical by itself. So some preliminary work here. Subtract 3 from both sides. And divide both sides by -2. And we accomplished our preliminary goal, which is get the radical by itself. Now what you do at this point is you get rid of the square root by squaring both sides, which then gets us x plus 5 equals 36. Subtracting 5, our final answer is 31. And if you want to plug that 31 in to check it, you'd have 31 minus 5 or plus 5 is 36. Square root is 6. Double that, you get -12. 3 plus -12 is -9. You could check it on your calculator also. But that's a legitimate answer, and we're ready to move on. And I'll do so in the